Hey guys, in this lesson we're going to take a look at another type of a transformation called a rotation. And a rotation is just moving a geometric shape in a circular motion around a fixed point. And there's two different options that we have for this circular motion. It can either go clockwise or counterclockwise. When we're doing the rotations in this class, they're always going to be counterclockwise. And then that fixed point can be anywhere in the coordinate plane. The fixed point that we're going to use in this class is going to be at the origin. And what that rotational point is called is the center of rotation, and it's the point where a geometric shape is rotated about. And again, for this class, it's always going to be about the origin. So we'll be looking at having a triangle, A, B, C, and it's going to rotate about the origin. So there's our center of rotation. And if we rotate it, it's going to look something like that. And unlike with the reflections, for the most part when you're doing a reflection, it's pretty easy to count one way or another to figure out where those values are going to be. I find that it's harder to figure out where the new shape is going to be than it was with the reflection. So I'm just going to be using the rule the whole time. So when you're looking at a 90-degree rotation, your XY pre-image, your X and your Y are going to switch, and you're going to do the opposite for your Y, and that's going to give you your image. So this is our old, and this is our new. So for a 180-degree rotation, given the original XY, you're just going to do the opposite of your X and the opposite of your Y. Looking at a 270-degree rotation, if you've got your X and your Y switch, and you do the opposite of whatever your X's are. And then they usually won't ask you for this, but just in case, if they ask for a 360-degree rotation, that's just going to take it all the way around and put it right back where it started from, so your points are going to stay exactly the same. So if we start trying these out, looking at the first example that we have, it tells us to graph the image of triangle FEG after a rotation of 90 degrees counterclockwise about the origin. So there's those keywords that I was telling you about. We've got to be doing counterclockwise and we've got to be doing origin, otherwise these rules don't work. So I've already written the points down, so I'm going to go straight to my rule that we have on the last page, and it says we're doing 90 degrees. So for the original point XY, to get our new point, we're going to do the opposite of Y, X. So if we write our new point, E prime, opposite of Y is a -2, and our X value is -10. Stays exactly the same. Our F prime value, the opposite of the Y value is -2, and our X value stays the same, but is going to be written second, so -3. G prime is going to be -7, -9. So if we graph those, because that's what it says to do, graphing E prime, -2, -10, -2, -3. So this is the E prime, this is the F prime, G prime, -7, -9. And if you notice, just like with our reflections and our translations, the size is not going to change and the angles aren't going to change either. So it's going to look exactly the same, it's just been rotated. So that's 90 degrees. Taking a look at 180 degrees, again, the easiest way that I found to do these is to take whatever points that they've given you, write them down, look at whatever degree rotation they have you working with, write the rule. The rule for this one is going to be you do the opposite of your X, opposite of your Y, and they stay in the same exact spot. And then write your new points, and then put them on the graph from there. So the opposite of x is going to be positive 5. The opposite of a negative 9 is going to be a positive 9. Q prime, opposite of negative 5 is a positive 5. Opposite of a negative 7 is positive 7. R prime, opposite of a negative 3 is a positive 3, and 0 doesn't hold a value, positive or negative, so it's just going to stay the same whatever it is. So S prime is going to be positive 3, positive 9. So then I'll go ahead and graph those. So we're looking at 5, 9 is going to be our P prime, and then 5, 7 is going to be our Q prime, and then 3, 0 is going to be our R prime, and then 3, 9 is going to give S prime. So connect all those, and there's that shape rotated 180 degrees about the origin. And you can see this one's 3 away from the origin, that one's going to be 3 away from the origin. And to double check, PS was 2, P prime to S prime 2, P prime to Q prime 2. So we know we at least have a chance of getting it right. Looking at the last one, graph the image of the trapezoid after a rotation 270 degrees. Just double check and make sure it really does say clockwise and really does say origin. So we're looking 270 degrees. So looking at that rule that we have there, it says we're going to take our original point xy, or our pre-image, and the image of it is going to be y opposite of your x value. So A prime, our y value is 3. The opposite of our x value is negative 3. B prime, our y value is 8. The opposite of our x value is negative 3. C prime, our y value is 10. Opposite of our x value is negative 6. And then D prime is going to be y value is 1. Opposite of x is going to be negative 6. So if we graph those, 3, negative 3, that's our A prime. 8, negative 3, B prime. C prime is 6, or 10, negative 6. And 1, negative 6. And there you go. And as a way to double check, 270 is kind of going to be through 3 of the quadrants. 180 is going to be through 2 quadrants and end up in the second one away. And 90 degrees is going to end up in the first quadrant away. That's if it's nice and neat and in one of the quadrants looking like that. If it overlaps, it's going to be a little bit different. But that's another way to double check, is you can look and say, okay, 90 degrees is going to be 1 quadrant away, 180 degrees is going to be 2 rotated, oh, this way, my bad, 2 this way, because it's counterclockwise, and then this one's going to be 3 away. Okay? If you have any questions, be sure to write them on your paper and ask when you get to class.